So it shows we're live. Is there a recording button I need to push to, Heather?
No.
I linked my LinkedIn, but I did not.
There's a delay. There's like a 8-second delay on LinkedIn. So I'm going to hang on, and when I see it, I see pre-live. So you're recording. So
It's recording?
I think so. Just takes a few minutes for it to go live.
I just know that I did not put the link from LinkedIn in there, but maybe it's connecting it somehow.
It's streaming through your account. Let me go to Tony's and see. Tony Mormino. We'll see if Tony's live. It says starting soon.
I got to figure out where to add this stream link from LinkedIn to connect them, I feel like. Let's see.
Let's see.
The question is where to add the LinkedIn stream URL.
Go to the dashboard and Restream. Select Set Up for OBS or Zoom. Click Embed Stream at the bottom of the screen.
You talking about go to settings?
Go to the dashboard and select Set Up for OBS or Zoom.
I don't see where that. Oh, let me leave site. I'm not sure where setup is.
I just commented on the LinkedIn page, just having some technical issues. We'll be starting shortly, just so hopefully people see it.
You've added your profile.
Visit your software's help center to learn more. Not sure where to put the key and URL. Visit your software help center. In your broadcast software, start streaming, and you'll see the preview here. When you're ready, click go live. So I'm going to try this again. Get URL, and I'm going to copy that. Then it's going to say here, I need to go to help. Need help. Message. URL key. LinkedIn. Connect Zoom to Restream. Stream an existing LinkedIn event. So go to the Restream home screen, schedule an event. I did that. Enter the title. I did that. Toggle to the LinkedIn to your LinkedIn. Connect existing LinkedIn event. Toggle on your LinkedIn channel, then click connect an existing LinkedIn event. It says we got up to 2 hours to do this, so we'll get it. Choose a LinkedIn event. Toggle to on any other channels you want to restream it.
But check your email. Make sure you're not getting something from Restream.
Just verify the device.
Okay.
All right, so connect a LinkedIn event. So the network connected this LinkedIn event. You can only connect a LinkedIn event to a Restream event up to 15 minutes before the scheduled time. After that, it enters a pre-live state. You can link your LinkedIn event to a new or existing Restream event. When you create a Restream event using a LinkedIn event, those event details, date, time will apply to all other enabled channels. I'm going to try to go out of this
Well, two people are going to be you and Jason. Send me the link and see where it goes. You can email it to me.
Can you hear me?
Yeah, I can hear you. You still there?
I'm here. Can you hear me? Yeah. Is that all right? Is it working?
Yeah. We're live. I think we just created a different event than the actual one that we're trying to go to. So
Okay.
yeah, it's a little bit different, but I think we're live. So,
Should we try to reshare the?
Email me the link and let me see if I can drop it.
all right, Jason, you still there, right?
Yeah. Can you not see me? I got my camera on.
Yeah, let's do this.
Can you?
So-
You can hear me and see me okay now?
I can. Yep.
Okay. Good.
Sorry, everybody, for the technical difficulties. We are obviously stepping in here for Tony Mormino, and we get started in just a second here. So, all right. So, welcome to the Engineers HVAC Podcast, where our mission is to educate and empower the commercial HVAC community. My name is Matt Warren, and I am your guest host. And thanks for joining us. This is very timely material. We've got Jason Jones with Fellows with us today. He's going to give us a quick rundown on some short-term and long-term vision for indoor air quality. And I appreciate you hanging out for all of the little technical difficulties trying to make this work. Tony makes it look so smooth, doesn't he?
You can't tell we're rookies at this at all, right? This is just off to a blazing start.
Yeah, well, we can always redo it and make it up if we need to, but just thought we'd get going here. So, the Engineers HVAC Podcast is brought to you by a family of amazing HVAC rep firms, including but not limited to Hobbs and Associates, Insight Partners, Faulkner and Haynes in the South Carolina, North Carolina area, and all of the air control concept brands and companies. So thanks for listening, and I hope you enjoy it. And that's the little spill that Tony normally gives to start off the podcast. So, Jason and I were talking about what can we do to help Tony and the Asheville office. They got devastated by this the recent hurricane, tons of flooding. And right now they're in all the cleanup efforts, trying to dry out the buildings. And with that, all of us know comes things like mold and unwanted odors. And we're just trying to use this as an example of maybe there's some solutions out there that people don't know about that could help in this situation. So, Jason, tell us a little bit about yourself and your background.
So yeah, thank you for having me, Matt, and thank you for everyone who's stuck around and while we worked out the kinks and got this to go live finally. And yeah, so I'm the senior field sales director here at Fellows Brands. You may know our air purifiers. You may know some of our other office products, our shredders and those lines. And I think we had been trying to get together, do a little podcast for a while. And we said, hey, you know what, rather than have something be formal and rigid and scheduled, let's just get on and start talking and hopefully make Tony proud. And I'm sure we will. I know he's knee deep in some mud, dealing with all the fallout of the hurricane. And yeah, so that's kind of what got us here. We started talking about what he's going through and the fallout of all of that. And now here we are to talk about indoor air quality, kind of post flood, post natural disaster, and just for the future and what we're doing for the Asheville office. I mean, first and foremost, obviously, there's a lot of work being done down there, and I commend those guys for rolling up their sleeves and digging in, and Tony and his team. And I was watching some of his videos earlier today about kind of how to clean out and how to dry out some of your space. So obviously a lot of work to be done before a solution like ours gets involved. You obviously have to get in there and get the water out and dry out the building and just get back into the space. But what we're doing with you all in your Asheville office is kind of helping in our small way with some of our products, some of them from the monitoring side, some of them from the air purifier side. So obviously, like you said, mold, big risk after a flood. Even after things get back to normal, even if you can't see it, it can still be in the air. The mold spores, it can make you sick, and there's a lot more to it than just that. But so part of what we've been doing is you can see the air purifier above me in my virtual background, and the one in the background there. Tony's going to have some of those in his space going forward to hopefully help clean up whatever is left in the air once he's done doing his cleanup. And we're working on getting some of our sensors down in there so he can measure and monitor and also mitigate some of the contaminants that may be left lingering around. And hopefully they do a good job drying it out. But if not, at least we'll have a good way to kind of keep an eye on things and make sure that things are going as planned after all the remodeling is done.
Yeah, those little devices that you held up, I'm excited to share with the audience more about that. That really is something that is revolutionary. I know when I was first learning about your products, this whole concept of measuring, mitigating, and monitoring the whole system really is what sets you guys apart. There are companies out there that do one or two of these steps, but they don't do necessarily all three of them. What were the 3 M's?
Measure, monitor, and mitigate. So
measure, monitor. I might have got them backwards there, but measure, monitor,
okay.
and mitigate.
You can mix and match them any way you need to. Yeah, so this is part of what makes us unique is that kind of 3-step approach where we're measuring a lot of the issues you're going to see, and we're trying to tie this in, make it relevant, right, to the flooding that we've all seen, but it goes across lots of things: wildfires, pandemics, anywhere there's an airborne concern. Certainly measuring, monitoring, mitigating are important topics. So we'll reference Tony and his ongoing struggles down there to clean up and get things back in order. But I think it's pretty ubiquitous, right? You need to be able, you can't fix what you don't see. So if you're not measuring the contaminants, the potential pollutants in the air, you're not monitoring that situation, there's really no way to mitigate against it. So this little puck that I kind of held up, and this is our signal. This little guy is going to be able to kind of monitor in real time and measure the particulate matter and the temperature, the humidity, the pressure, VOCs, specific to mold, we're going to be looking for the humidity levels very closely. We're going to make sure we want to make sure that we're keeping that humidity low so we can inhibit the growth of any mold. But also we'll be looking at the particulate to see if there's any spikes where there may be some mold spores being released and things like that. And then the air purifiers, as I mentioned, we're gonna help Tony get set up down there. Once he's back in the space, they'll do the same thing. They'll monitor the same way. They'll be able to report back in the same way, but they'll also be able to use that data to adjust their fan speeds. So just like your thermostat adjusts your HVAC system, depending on what the demand is, the air quality is the same way. So we'll be able to help him kind of get back in. And I think that the tagline was crisis to comfort, right? We want to get it. We know that we're kind of in the middle there right now, and there's probably a rebuild stage in between that we're still going through, but hopefully, out the other end, we all come out of this a little bit better and stronger, and the comfort will be back, and he can rest assured he's in a healthy space.
Well, like for his office in particular, tons of flooding in there, and once it gets dried out, 2 months from now, let's say they're rebuilding and starting to get back to normal. I don't know that time frame. I'm just throwing out a date, but how do they know that stuff's not growing in the walls, right? I mean, how do they know? And these devices were very timely.
That's
a piece of equipment,
Yeah, that's certainly the risk. And like I said, we want to make sure that we're listening to our experts as we're, and the local contractors, the local teams down there that are helping them kind of do the demo work and do the rebuilding work. And certainly, listen to your Insight rep. They're going to help you design your HVAC system coming out of this so that it gets you the proper ventilation you need and is properly sized to make sure that your building's being properly ventilated. But just being able to kind of know in real time and see those indicators of poor air quality. It's the kind of the difference between monitoring and doing a test. So we'll be able to kind of give you that canary in the coal mine, let you know that there's an issue that you need to address, and that's where you can kind of take those next steps. And we've seen that with a lot of clients, beyond just a natural disaster. We had a recent customer who had an issue with some construction in their building, and some of the chemicals that were being used in the construction made their way into the different floors of the building, and several people ended up going home sick. A couple ended up in the hospital. So at the time, they did not have any monitoring tools in place, and of course, a few days later, by the time they were able to do a test on the air quality, whatever contaminant had been there had since gone. Right. So it was just kind of that moment snapshot in time. But fast forward a few weeks, and construction was back at it. And this time they were equipped with monitoring solution. They did have our signal pucks in there, and they were able to see a measurable spike across every floor and every space of their building. And they're able to send people home early so that they could avoid, the risk, the health impacts, and frankly, the liability of having people in an unhealthy space. So, they were able to immediately after that, that monitoring piece, that initial alert, bring in some next level testing to start to figure out, is this contaminant something that's hazardous, or is it something that is just kind of naturally occurring? So it's just that bit that helps you be more aware.
So if we could just step back a little bit for people that maybe have no idea what Fellows is, what Fellows does, from an air purification standpoint, it's really multi-faceted. We've got this device, that little hockey puck looking thing that you were talking about, that is a wireless device, right? That's independent from the HVAC system. And that really is something that it's freestanding. So you could put one of those in each office room or wherever you need them. But say you had 20 offices, and there's one in each office and one in the lobby, for example. You could, with a dashboard, view all of those rooms, right?
Absolutely, yeah.
Know real time what's happening. Not only that, but go back and look and say, okay, we see a trend around 8 in the morning. It really ramps up, right?
Yep. And that's exactly what this customer did. And you can kind of, like you said, you can see the historical data, but in real time, you can get alerts to your air quality. So you can be warned that you're maybe in a situation that requires some sort of activity, some sort of mitigation or mediation to intervene. The other piece of this and this kind of an enhancement that'll be ready for the back half of this year or later this year, early next, which is a BACnet integration. So kind of the next evolution for us is to be able to take all of those sensors and, most HVAC systems are going to look at temperature and humidity and maybe CO2, maybe not, but depends on the system you have. As you said, wirelessly, we can connect this data into the BMS system. So you're getting that PM1, the particulate matter, PM2.5, PM10. Those are the airborne solids. And then you've got your VOCs as well as CO2 and temperature and pressure and humidity. So you're able to feed a wealth of data back into the building management system. And then the HVAC system can assist. So this is kind of a complementary system to the HVAC. We're going to supply you with a ton of extra data. Our air purifiers will do a lot of the heavy lifting. We'll be able to clean that air for you in that space, but we'll also be able to give you some of that demand control and ventilation information so your building can react and kind of work in tandem. And it's just a neat way to kind of make your building smarter.
That's like, air purification 2.0, like, or even more, not only are we able to measure it and monitor it, but we're actually going to be able to, like with a VFD, you can ramp up, or a VRF system, for example, on HVAC, it ramps up and ramps down as demand happens. So what you're telling me is when this device, the signal device, picks up a signal that, hey, something's happening, maybe 20 people came into this conference room, or somebody started cooking in the kitchen and it's creating a bunch of pollutants in the air, it's going to be able to communicate with the building automation system or the building management system and cut on the ventilation or cut off the ventilation or cut on more supply air. Is that correct?
Yeah, exactly. And if I can figure it out without any more technical issues, I'll pull up a slide. So I'm going to roll the dice on us, Matt. So bear with me. We're going to try this, and hopefully we can get through.
Because while you're playing with that, in the past, what I know some people have done is they'll go out and buy an air purifier, right? And they'll just leave it running all the time. Well, it's wasting a bunch of energy, and it's just not needed, right? So let me see if we can share here.
So let's see if you can get that. All right. Hopefully that's full screen and you can view it well now.
1 second. Let's play around here with this. Yep. Is yours full screen on your end?
It's full screen on mine, but I can no longer see your screens or the restreams. So I'm just want to make sure you can see. You're not looking at the edit view or anything.
We've got a different view here. I can see like half of that. Scroll over to the right a little bit. There you go.
Is that better?
There you go. Yeah, that's better right there. Now
it's not letting me present, but I'll do my best with what we've got here.
Yeah, I can see it.
Hopefully that's
so what are you showing here? So there's a big
so this is real time, real world example of what we're hoping to accomplish and what we're trying to communicate here. So this goes back to last summer when we had the wildfires in Canada that were kind of blowing down across the U.S. and depending on which way the wind blew, the Northeast got it, Florida got it, Chicago got it, and in this example, this is a office building right outside of Chicago. And you can see on the 27th, the outside air quality was really poor. On the 28th, same thing. In fact, the air quality was really poor because of the PM2.5. That's that ultrafine solid particle from the smoke. But what was happening was the HVAC system in this building was designed such that it would pull outside air in early to help cool the building off before people arrived. The issue was, of course, the system didn't know that it was by doing that pulling in all this particulate matter, all this wildfire smoke. So we happened to have sensors in that space, and they were able to see in real time that the air quality was just taking a beating. because of all the smoke. The HVAC system was doing its job, thought it was doing the right thing, but it was actually increasing the level of contamination indoors. So after seeing this data on the 29th, they were able to adjust the HVAC system to stop pulling that outdoor air in, and then the air purifiers were able to quickly get the air quality back under control, back into a healthy level.
So the interesting part about all this, at least interesting to me as like an HVAC nerd that likes to study this kind of stuff, is that if the event was different, so if they were having construction happening indoors, or somebody was cooking a bunch of food, or whatever the issue that would cause the indoor air quality to go bad and spike like this, normally you would communicate with the HVAC system to bring in fresh air. Right. But in this situation, when you bring in fresh air, it's actually bringing in the smoke and the smells from outside and the pollutants from outside. So you're able to communicate with the building management system, and you will be able to, it sounds like, tell it, hey, if it's coming, it's coming from outside, don't bring in fresh air from outside because it's not fresh air, right?
Yeah.
Is that a fair statement?
Yeah, exactly. And this is, different parts of the country. We think of fresh air. We think of all outdoor air as fresh air, but we know that there's some urban areas where that's not necessarily the case. We know that, wildfires, certainly not always the case. Chemical spills, we've seen enough of those the last several years. I saw an article the other day about the PFAS, the forever chemicals, are in higher concentrations along shorelines because they're aerosolized by crashing waves. So there's just, an infinite number of things that can affect the air quality in a localized area. And if the system for your building is set a certain way, it only has so many data inputs to work with. And the more data it has, the smarter it can be. And that's kind of what we're trying to help achieve here.
Nice. All right. Well, if you want to stop sharing there, yeah, we're back to where we were. So
there we go. We're experts now, Matt. We got.
We're pros. Yeah, apart from I tell you, we miss our Tony Mormino back in the saddle here. Can't wait to get him back.
Moonlighting as a ditch digger right now, cleaning up mud. So it's.
I'm telling you, they really went through it all. So again, using that situation with the flood system, so we're sending down these little signal devices for people that are going through any kind of natural disasters in the future. This is what we're doing, real world scenario. That's why we wanted to jump on this real quick, even with all our technical difficulties, to try to bring you what we're doing real time to try to help that situation. So we're going to put one of those signals in each of the offices, and then the filtration system, like the one above your head and the background that you've got there, that's going to be able to clean up the air as it's being detected real time. So
yeah, exactly. And this is, and I know we're picking on Tony a little bit because he's not here to defend himself, although we wish he was. But way beyond this, right? We've seen a lot coming out of the pandemic that air quality is just finally becoming top of mind for a lot of folks. It's one of those things that is, what's more ubiquitous than air, right? It's just goes without saying, but we control what we eat, we control what we drink, we take care of ourselves. We can't control what we breathe. We just don't have that option. So we learned that during the pandemic the hard way, that there's a lot more that a lot of other precautions that could be taken. One of them, of course, is just purifying the air, right? And we've kind of see that as kind of this trend that's growing more and more when we look at things like ASHRAE 241 and the future of air quality. We see legislation that's being proposed now. And basically what it's coming down to is we're realizing that maybe the requirements for air quality based on old ASHRAE standards around CO2, left a little to be desired. That's it's not a bad thing. We're always evolving, learning from past experiences and new experiences. So part of what is evolving now is that, like you said, the air purifier above me and the one in the virtual one in the conference room built in over there. These are smart machines. They're connected to your BMS system, BAS systems, just like the signal would be. They are able to inform themselves of the contaminants in the room. So To your point, we were kind of getting by with a plug and purify air purifier during the pandemic. Now we've evolved past that stage, and what we're looking for is something that's part of that smart building, part of that building that is just more efficient and more effective. So we'll give you the additional equivalent air changes you need to meet those new ASHRAE standards and to try to achieve those better indoor air quality and wellness goals. But we're going to do so in a more efficient way, and by that I mean our goal here is to try to reduce energy consumption, or at least stay neutral in the world where there's a lot of other climate change and other competing issues. We know how much energy buildings use in heating and cooling. We saw during the pandemic a lot of people introducing higher grade MERV filters or extra outside air. All this in the hopes of achieving cleaner air in the space where you and I sit, where people occupy. But that had a bit of a negative impact on the energy consumption of those buildings. So now with smart solutions like the Fellows Array products, we're just trying to help people get that clean air, but also stay within their energy goals. And you're probably thinking, okay, you're going to plug this in or attach this to the power supply. So how are you going to do that? Like that sounds counterintuitive, but a couple ways. One of them is, as I mentioned, people made those upgrades and enhancements to their HVAC systems. There's some studies done that showed like an 8 to 13% increase in energy consumption by moving from a MERV 8 to a MERV 10 or a MERV 13 filter. So that 8 to 10% increase in energy, you can get back to where you were before by relying on a HEPA purifier to do the job as opposed to your HVAC system. And the same thing with that additional outside air.
So we've got a lot of data coming in with this, indoor air quality measuring device, right? So if you're a facility manager and all of a sudden you're getting information like CO2 and VOCs and PM1 and PM 2.5 and humidity, what are you going to do with all this data? Like what good from a practical standpoint, if you're the facility manager or you're the building owner, for example, why do I need all this information?
Well, the first thing you're going to do is call your Insight rep, your air controls rep, right? That's your first move.
Jason, shameless plug.
A shameless plug that would make Tony proud. Well, I mean, and that's kind of the whole point is what do I do with that information, right? That is kind of the ultimate goal is if I didn't have that information before, I couldn't have done anything, right? I couldn't do anything because I just didn't know what was happening. Now I can do all sorts of things. I can look at an extra level of filtration. I can look to see if there's a leaky pipe somewhere. I can reach out to my HVAC partners and say, hey, I might need a duct cleaning. What does this mean? I'm getting imbalanced pressure throughout my building. I'm getting imbalanced temperatures. I'm seeing humidity spike in these sections. It just allows for a conversation to happen to solve the problem. So we don't have to just kind of limp along with inadequate or ill repair in our systems. They can be efficient, but we can't do that without more information. We can't do that without the data.
It takes out all the guessing, doesn't it? It's like we might think we know what our building's doing as far as indoor air quality, but until we have a wireless device that's actually tracking all of it, independent from everything, it's like a third-party auditor almost for your building. It's able to capture all this information, and then we can do with it what we need to do with it to fix the problem.
Yep, exactly.
From a learning standpoint, trying to learn the system better and learn all about what it's actually able to do. I put one of these signals. If you don't mind holding it up one more time.
Sure.
Mine's
currently telling me that the CO2 levels are too high because I'm talking too much right over it.
I took one home and I've had it in my house for about 45 days or so. And it's not in my kitchen, but it's next to the kitchen where I have like a little breakfast nook office area. And I keep it over there. And I haven't told my wife what all it's tracking or what all it's doing. But it's pretty neat because I looked at the information before this call, and it shows, early in the morning when we start to cook, cook some breakfast, cook eggs or whatever we're cooking in the air fryer or whatever, it actually, you can tell it peaks and it goes up. And then when we go away to work and we're gone for several hours, it actually shows that it actually says like a 0 to 100%. So 100% air means it's good air. It's clean, and it's the indoor air quality is 100%. But maybe my wife lights a candle, right? We're cooking dinner and then we blow out the candle and you got a whole bunch of smoke in the kitchen or a whole bunch of smoke in the room. You can see that percentage drops down from 100% down to 45 or whatever.
Every time I light my fireplace, I see the air quality take a hit, and I know they're not good for me, but it's just so nice. So it's kind of but the air nerd in me sees the data, but then, the guy that just wants to sit by the fire and relax sees the fire. So it's kind of an internal struggle, but you're right. It is interesting. Once you see those triggers, you start to wonder, is there, what can I do to improve the air quality? What is it? Is there something I need to be concerned with? And like I was saying, sometimes it's something harmless. Our system will respond to all odors. It doesn't know that perfume smells better than burnt popcorn. It just knows that there's something to remediate and something to work on. Without that data, there's nothing you can do.
I know from a commercial standpoint, because we really don't do residential work, but what a better place to test it than my house, right? So I put it in my house as far as learn the system. But we're doing this in like commercial buildings where they have restrooms in an older building that the restrooms smell rough, able to monitor it and purify that air. I'd like for you to talk for just a second about what we've had the conversation, not just from a one kitchen scenario where you've got one signal device, but if you've got a large, say, conference room that's got 3 or 4 of these devices in it, 3 or 4 air purifiers, or even 5 or 6 or whatever, talk about how they communicate.
Sure. Yeah. So the connectivity of it, the networking of it, isn't just to feed the data back to the dashboard. It also networks the machines to a cohesive unit. And if you can picture if you look at above me, it might be a little hard to see, but there's 3 different air purifiers that are above me in this image. You can network them in such a way that they'll work as a team. So in the lobby here that I'm, virtually sitting in, the CO2 levels are rising. The VOCs may be rising because I'm here. We're in this space talking. That machine's going to tell the other machines as it starts to ramp up its fan speed, hey, I need a little extra help here. Basically, there's some contaminants in here. There's some activity going on in here. So let's work together. So, we can pick on Tony a little bit more, I guess, and kind of fast forward to a day when he's back in his office and he's doing one of these podcasts with us. When he comes into his office in the morning, that air purifier is going to be in a standby mode. But when he turns the lights on, it's going to kick up a little bit. It's going to detect that presence, that occupancy, because generally we bring the contaminants with us in a lot of cases, and B, we consume those contaminants. We're the ones breathing the air, so that's when it's most important to purify. So that air purifier is going to go out of that energy save mode into those air purifying modes at a higher level. But let's just say Tony's got a podcast going and he's doing a lot of talking and he's got some chemicals in the room, or he's talking about some new systems and there's odors coming off of the metals or the motors. That air purifier is going to detect that extra level of activity, that extra need for air quality, and it's going to ramp up. And if it's speaking with any other air purifiers in the space, it's going to share that information. They're all going to work together to just remediate that much faster.
Yeah, I thought that was fascinating how because they're all connected. Traditionally, if people go out and buy an air purifier and they put it in the room, it's definitely not talking to anything else, right? So it's
best case, it's going to talk to your phone, and that's not doing you much good.
Yeah, but you were saying that, like for a classroom, for example, if you have a situation where you want it to just all of them to cut on and clean out the classroom, and like cycle that air one good time before everybody gets in there, you could set up a schedule that says all of them cut on at 6:45 in the morning before everybody gets there at 7:30 or something.
Absolutely. Yeah. You can set a schedule. And so take that classroom example. Before the students come in every morning, overnight, the system's going to know that the rooms are empty and dark. So it's going to stay into that standby mode, even regardless of what the air quality does. But once it knows that schedule hits, I can do a deep cleaning from 6 to 7, and the students arrive at 7:15. And when they arrive, they've got a clean classroom and they've got a fully automated smart system that's going to watch the air quality for them and just constantly adjust based on the needs.
Oh, that's great. Do you mind speaking for a second about the legislation? You mentioned the Tonko and Fitzpatrick bill to try to improve indoor air quality and what that's about.
Yeah, there's a lot going on, a lot of buzz right now. Hopefully, things move forward, and it seems pretty common sense. But I think we're kind of at a moment where it's similar to what we saw with like the Clean Water Act and decades past. We've had the blinders removed. We see that there's a real need for some legislation and just getting some code around things. And ASHRAE is kind of helping build that code as they do. But this legislation is helping to provide funding for those upgrades around ventilation and air filtration. It's helping solidify some of the guidelines around the air quality standards, and also kind of that monitoring piece of it. So we talk about measure, monitor, and mitigate. The legislation that's out there now is trying to coalesce some of that effort into something that's cohesive, that's kind of simple to follow, but also hopefully government funded, right? We need some funding to help support the efforts. It is an investment in people's health and well-being, and we know that tends to not always be the first investment people make. But in schools, in public buildings, especially, we certainly need to see that happen. Especially, when we think about schools, and we've got a lot of kids together, coughing and sneezing, sharing germs, trying to learn. We want them to have the best possible space. So hopefully these legislations or some form of them passes. But the goal for them really is to bring some funding to those new guidelines that are outlined and be able to really move that ball forward and kind of codify things a bit.
Oh, that's awesome. I think the trend here is that it doesn't matter if it's an old school that's got smells and odors, or if it's a building that just went through a massive flood damage, or a building in the middle of a wildfire area. It's the same technology, right? It's the same solution for all of those. It's gonna the 3 M's, as you say, which are my favorite. I think we should say it a couple times, but measure it. It's going to measure it. It's going to monitor it, so we can see trends over time, right? And then we're going to not just learn how bad it is and see how bad it is over time, but we're actually going to be able to do something about it and mitigate it. Can you talk about the technology from the mitigation standpoint? I know there's a lot of with other products that I've seen or have been introduced to in this industry. Sometimes you get put in this box of snake oils when you're dealing with certain technology. And one thing that I really found fascinating about what you guys offer is that it's filtration, right? Yeah. It's not some snake oil that it's hard to understand and people can't wrap their head around. It's something that we've been doing for a long time. Just speak for a minute about that, if you would, please.
Yeah, of course. And there's certainly some emerging technologies that we're keeping our eyes on. We're not completely shutting off those additional technologies or potential new technologies out there. But there's really 2 tried and true methods for purifying the air. And you saw that during the pandemic as really being the ones that were promoted most by the CDC and the World Health Organization. One of them is UVC, which we've seen when it's done right, it's effective. And we have a unit that does UVC right. And by that, I mean, you have to slow the air down to the right speed so you get enough dwell time so that the bulb's intensity level is sufficient to cleanse the air, to sanitize the air. But the other, and probably the one that's nearest and dearest to my heart, is through a true HEPA filter, an H13 filter, which is what we use. H13 is just a higher standard of HEPA. It's the European standard. But essentially, it's a physical capture filter. And I have another slide that I can try to pull up, and hopefully this one will work without any any hassle.
You
Bear
can
with
get
me.
2 for 2 here.
Let's see.
Let's see here.
Says I'm
There you
sharing.
go.
All right.
Yep.
Well, you know, I will say, just interrupting myself, I did try to pull this slide up for us when we were having our technical difficulties, but even that didn't work. So so be it.
That's right.
We'll keep going.
We're rolling now.
Yeah, we're good. So what I've got on the screen here is just kind of the way our HEPA filters work. It seems simple. The science behind it is actually kind of complex, but it makes sense when you dig into it. But as the air passes through here, I mean, they're a high efficiency particulate filter, and basically just we're able to move a lot of air very quickly and capture instantaneously. So we've got a pre-filter is going to capture that extra large particle, think hair and dust and pet hair, things like that. Next, where the really interesting stuff starts to begin is that activated carbon filter. So that's where you see the odors and VOCs start to get absorbed. And then the real workhorse of it all is that HEPA H13 filter. So this all-in-one filter is going to capture the large dust particles, the odors and chemicals in the air, and then those ultrafine particles in that HEPA filter. So all in one simple filter, you're going to get everything you need to cover the air.
That's neat. So the air there is moving from the right to the left of the screen.
It is, yes.
And each step of the way, it's getting more filtered, more filtered, more filtered.
Exactly. Yep. And then, you know, on the other end of it, you're seeing a 99.95% at that 0.1 micron. And, you know, what we've seen during the pandemic, you were talking about, you know, some snake oils and things. We all saw them. I think everyone in the industry saw some less than reputable solutions being proposed. And I think it was frustrating for those of us who were kind of out there helping people solve problems and do the right things. But we've as an organization, we've gone out and made sure that all of our filters are proven effective against the flu and COVID, just those two being kind of the two biggest killers when it comes to airborne pathogens, but also, you know, passing those tests and being certified. So it's just something you want to look for. Hopefully Fellows brands, but if not, just look for those accreditations just to make sure you're getting a high quality product.
So let's switch gears real quick to the long term. What do you see as far as a long term IAQ vision? What do you think is coming down the pipes?
Yeah, I think, you know, our next big step, which I think is a crucial one, and it's coming up very quickly for us, and hopefully we'll be able to talk a lot more about it in the near future. But is that backnet integration I was mentioning? So being able to tie back into the building system and be that true companion system to your HVAC system, right? You need the heating and cooling, you need the climate control, you need the humidity and the ventilation, of course. But as I was saying, some of those new standards coming in, being able to find that sweet spot, so you're getting the cleanest air you can for the most efficient energy use, while keeping your climate controlled where you want it to be, is a balancing act. And as I keep saying, you know, it requires data, requires information to be able to get that right. And being able to feed the data that we're creating back into the building system so that it can dial up and down the outside air or the filtration, and kind of work in tandem in both directions. And having the units work in hand with your HVAC system so that it can be as efficient and effective as possible, is really the next step. That's the next evolution where we've moved beyond a plug and purify. There's certainly places for them. And, you know, if someone sticks one in their office after this flood or after a wildfire to help out, it's absolutely a good solution as a stopgap solution. But I think the future really is that fully integrated, fully immersed system like this, where we've got, you know, blended right into the space, designed right into the space, and kind of hidden in plain sight, but providing that data in the background.
Yeah, and if you were to ask me, all of that, but also like from an energy standpoint, I know we're not here to talk about energy, but it takes energy to run these things. You know, what I loved that you said was, if it's 4 a.m. and nobody's in the office, but for some reason it picks up some sort of, you know, high levels, it could be so smart that it doesn't even cut on, right? that unit above your head, you said had a light sensor and it had a
sound. Yep.
A light and a sound. So it knows when people walk into a classroom or walk into a busy office. But if nobody's in the space, it's not going to waste that energy. It's not even going to try to cut on, even though it might detect something. What are your thoughts on that?
Well, and that's kind of the goal here, right? Is to outsmart even the smartest system. We see a lot. The HVAC systems do this, right? They'll shut down at night, or they'll go into a different setting at night, different thermostat setting. We've watched with our sensors overnight in our own buildings where the VOCs creep up at night because the ventilation's been reduced. We see it happen all the time. The natural off-gassing of carpeting and furniture is just creating this ever-growing VOC contamination in the space. But the fact that our system's smart enough to know that, hey, it doesn't really matter because air quality is only important to the person breathing it in at that moment. There's no one here to breathe it in, so we can kind of stay in that standby mode. That's where we really can accelerate that energy savings. And then once we are kicked on, like I said, we're kind of offloading some of the work that was being done by the HVAC system, whether it was a higher MERV rated filter or additional outside air. We can help offset some of that energy consumption there. And that being the single largest consumer of energy when it comes to commercial buildings, we can make a real big impact on the energy, but also, on the bottom line.
Yeah. And that like you mentioned also, what's interesting is where you live, it's like 70 degrees. So I'm in South Carolina, and it's, we're still using air conditioner.
I've got my heat on.
You get your heat on. But your shoulder seasons are a lot longer than ours in South Carolina. So like you just were mentioning, when the air conditioner's not running, you don't have that circulation that'll help to clean out those volatile air molecules, or the particulates. It's just stagnant air, right? Yep. So it takes a lot longer for those to come back up to 100%, like I was talking about in my house. Mm-hmm. If you're not circulating air, and if your air's not running because it's 70 degrees and it doesn't have a call for air, that's a little different. So with these freestanding air purifiers, what's neat about it is they can be doing their job of purifying without being connected and without having to have that air conditioner running in order to circulate the air.
Exactly. Independently of the thermostat, right? So that we're going to let the HVAC system do its job. It's got an important task to do. Let it do its job. And we've got another important task to do, and we can work together, but we can do it more efficiently.
Yeah. You don't have to just cut on the air in order to get some circulation.
Absolutely.
Well, that's all fascinating. Is there anything else that you want to comment on before we wrap it up here?
I do want to say thank you. I know, we had talked about doing a PDH, and I know some people were chatting earlier on the comments about a PDH credit. We absolutely were going to do a PDH. We just kind of did this. So anyone who was hoping to get that PDH credit, hopefully you found this interesting, and we'll listen in when we do the PDH and get you your credit for that. Hopefully you don't feel cheated and thought this was worth your time. I certainly did, Matt. I appreciate it. I do want to say to everyone who's been affected by the storms, and Tony and his team and everyone, our thoughts and prayers are with them. And it's heartening to see everyone pulling together in their communities and making an impact together. And we certainly wanted to come and just kind of leave with that and commend them for all the hard work they're putting in down there. It's a tough time, so we're here to support.
Yeah, and I wanted to make a note on that. Insight Partners and Faulkner Haynes are all teamed up, and we're collecting donations and working to support the mountains of North Carolina right now. If you have donation items, you can drop them off at any one of our office locations. And we're getting all those together and sending them up there to the mountains of North Carolina. And if you want to volunteer with Samaritan's Purse, we've teamed up with them. You can contact Heather Robinson on how to volunteer with that. So don't forget to drop off the supplies. We've got a list of supplies that they need out there, and we certainly want to help as much as we can. So the three things that I want to mention before we wrap up that I found one of my takeaways was measure, monitor, and mitigate. So a lot of places out there, they just do one or two of those 3 M's, but we have to measure it, we have to monitor it, but what good is all that data, right? We need to mitigate it to try to keep us safe. So thanks, Jason.
Thank you for everyone for bearing with us through the technical issues.
And this little outro here that Tony normally does, this is in honor of Tony, but thank you for listening. And you can watch this video version of the podcast on our YouTube channel, Insight Partners HVAC TV. If you know anyone interested in this podcast, please share. We would greatly appreciate it. Thanks again for listening and supporting the Engineers HVAC Podcast. We greatly appreciate it. Thanks so much, Jason, for your time.
Thank you, Matt. Take care.
Yes, sir. Thanks.